Okay, everyone, here we are, 12.2. In 12.2 and 12.3, we look at two specific types of sequences and their series. So here comes the arithmetic sequence and arithmetic series. We get that name because we always find the next term by adding the same number. So you see there the definition of the arithmetic sequence, adding the same constant to make terms. So from one term to the next, we're always adding the same number. Got this nice simple pattern. Whatever number we add each time, we call it the common difference, and we describe it by the letter D. Okay, so let me give you an example here. Do something fairly simple. Let's say we have the sequence 2, 7, 12, 17, 22, ... and so on. Okay, well, what are we always adding every time? What's the common difference? And of course, it's 5. We're adding 5 each time. Okay, so that's the idea. D, by the way, D could be negative. I want to say, oh, I've got an example here. Perfect. How about this one? The sequence 20, 9, -2, -13, -24. What are we adding each time? We still think of it as adding. It's just going to be adding a negative. And of course here, D is -11. So we imagine adding -11, which is really subtracting 11, obviously. Okay. So we'd like to know, what is the general term of an arithmetic sequence? So they take this nice form. You could say this is the formula for an arithmetic sequence. The nth term, a sub n, equals a1, the first term, plus your common difference d multiplied with n minus 1. Okay, so we will have values for the first term, and for d, this is always going to be times n minus 1. So if we think about how that relates to our previous two examples, I don't think it'll all fit on the screen at once, but that first example, the 2, 7, 12, 17, 22, ... you could describe this way. The first term was 2. Common difference was 5, so 2 plus 5 times n minus 1. And if you want to check, right, I don't think I wrote this on my actual lecture, but if you wanted to check, say, okay, a1. Well, what do we do to find a1? We plug 1 in for n, right? So that would be 2 plus 5 times 1 minus 1. Well, that's 2 plus 5 times 0, which, yeah, when you multiply by 0, that just gives us the 2. That was the first term. How about the second term? Well, we'll plug in 2 for n. So now we've got 2 minus 1. Well, that's 2 plus 5 times 1. Now we are adding 5. We get 7 for the second term. And, oh, okay. Yeah, I see how that works. How about the other example that I just pulled off the screen because it doesn't all fit? So we said the nth term, an, the first term is 20. And the common difference was -11. So we write minus 11 times n minus 1. And yeah, if you wanted to check that in a similar way, you know, a1, plug in 1. Well, that means I'm multiplying -11 by 0, so I just get the 20 for the first term. The second term is a2, so I put 2 in. Well, 2 minus 1 is 1, so it'd be 20 minus 11 times 1. That ends up being 9, right? And we could check more if we wanted. So remember this, this formula for the nth term of an arithmetic sequence, and you know, it's nice. Pretty simple. Okay. So what might we do with this? Okay. Going to get these sort of questions. So of course we're talking about an arithmetic sequence here, although it doesn't say it in the problem. Find a15 where a1 equals 6 and a3 equals -2. Okay, so they're giving us the first term. They're giving us the third term. We need to find the 15th term. So it turns out there's more than one way to solve this. And I don't care what way you go. I actually like to see a variety of different solving methods. I think that's really cool. So if you've got a different idea than the way I'm about to show you, hey, go for it. Here's the way I would approach this. I'd say, okay, I know A1 and I know A3. I'd really like to know the common difference, because then if I know A1, then I can write out the formula for the nth term, and I can quickly find A15. So here's what I'm going to do. I'm going to just write out A1 equals, A2 equals, A3 equals, and I'm going to go ahead and fill in the parts that I know. I know A1, I know A3, right? So I'm going to think, okay, from term to term, I'm always adding the same number on, right? And I think this one is simple enough where I could just maybe kind of visualize what I'm adding each time. What do I need to add to go from 6, something in the middle, and then -2? You think about that. Well, there's a difference of 8 there, right? And it's actually going down, so D is negative here. What am I subtracting each time? I think I'm subtracting 4. -4 minus 4. So if I subtract 4 once, I'll land at +2. If I subtract 4 again, I'll land at -2. D must equal -4. I can just kind of visualize that for this problem. Now, if I wanted, maybe if it wasn't so easy, you could set up an equation for this. You could say, hey, 6 plus 2D equals -2, right? If I add D twice, plus D plus D. 6 plus 2D lands me at this. And if I solve for D, if I subtract 6, that's -8. If I divide by 2, that's -4. I could get D that way. But I like kind of this approach here. The numbers are small enough. I can just sort of, guess my way. All right, sort of use more intuition there. All right, so anyway, what's the point here? Well, then I can write my nth term, right? AN equals A1, which we know is 6, plus D, which we know is -4 times n minus 1. Perfect, I'm looking for A15, so I'll just plug 15 in. A15, 15 goes in there. And, well, I end up multiplying 4 by 14. 6 minus 4 times 14. I did this earlier, but I'll just check. Yep, it's -50. And I got the 15th term. Okay, let me show you another approach, because, maybe seeing a variety, like, I don't know if I really like this. I think this is a really nice way, and I mean, if somebody asked me, that's how I would do it. But I wanted to show another way as well, just in case there's, different people have different leanings. So let's say from the start, okay, find A15 where A1 equals 6 and A3 equals -2. I could just state the nth term of an arithmetic sequence, and I could say, hey, okay, they told me A1, so I'm just going to fill that right in. I know that's 6. They also told me that A3 equals -2. So here's what I can do. Oh, I got it right there. What does that mean? When n equals 3, the term is -2. When n equals 3, an equals -2. Okay? So I'll take the -2 and put it here. I'll take the 3 and put it in for n, and I can solve for D. So very different way of getting to your answer. I'll plug -2 in here, plug 3 in there. I know that's 6. Solve for D. All right. I can do that pretty quickly, right? That becomes 2. Subtract, divide. Almost like we kind of saw that earlier as well. And then once I know D, all right, perfect. I'll put it in to my formula. 6 minus 4 times n minus 1. Find A15. Boom. Got it. I got to say, between the two methods, I really prefer the first way. But, you know, different people like different things. Okay. I think I will stop this video right here because in the next one, we're going to introduce the nth partial sum for the arithmetic. So I'll see you in the second video.